we discover an asteroid. We have a couple of data points on its position in the sky. You look at its speed, you get a Doppler shift on it. You get its direction, you plug it into the computer. There was some 20% chance it was going to hit Earth on April 13th, 2036. Did you hear about this asteroid when it was discovered? In the possible range of orbits it could have on that fateful day, there is an interval range where if it threads that keyhole, we call it a keyhole, it's a 600 mile, several hundred mile range. If its orbit goes through that range, Earth's gravity will be just right. Or rather, just wrong. All right? So that it will alter its orbit so that it will hit us 7 years later. So the test is it going to go through the keyhole? Problem here in America is that we're really good at blowing stuff up and less good at knowing where the pieces go afterwards. We're just less good at that, all right? So I don't want to blow up Apophis. Then we have two pieces, one headed for New York, one headed for LA. I don't want two pieces. So the kinder, gentler solution would be to nudge it out of harm's way. And all you have to do is nudge it so that it misses the keyhole. And that's only a 300 mile nudge, one way or another. And if you get it early enough, you give it a sideways motion. I'm headed towards you. Give me a sideways motion, a few centimeters per second, that accumulates so that after enough time, and I miss you completely. And in this case, you just have to miss the keyhole. 2029, that's the right amount of time in the future. Most of us will still be alive, we'd hope. And we can adjust budgets to make this happen. So all we have to do is engage international space agencies to do this. So what kind of Earth insurance policy does the world take out? How do you work that? And we have an Apollo 9 astronaut, Rusty Schweiker, with a webpage called B612, dedicated to studying not only the physics of asteroid collisions, but the politics of how to alleviate them.